Hey everyone, this is our lesson on simple machines, and by the end of this lesson, you should be able to explain the relationship among work, power, and simple machines, both qualitatively and quantitatively. So today we're going to focus on what a simple machine is, and then we'll talk about the math that goes with simple machines in the next lesson. So first, let's make sure we can define what a machine is and then what a simple machine is. So a machine is a device that makes work easier and can be a combination of a few simple machines. So the more complex the work is, the more complex the machine will be, but it's made up of smaller, simple machines. And a simple machine is a device that does work with only one movement. So that's why a lot of these complex machines are a mixture or a combination of these simple machines. So a simple machine will change the direction or amount of force needed to do the work applied, and it helps to overcome some force of resistance. So we do have what's called a resistance force, which is what's acting against the object or the person doing the work originally. So there are two forces involved when machines do work. And the first one is the effort force, and that's the force applied to the machine. So if we are using a simple machine, we apply the effort force. But then the resistance force is the force exerted by the machine onto the object. So the force of resistance is what we're trying to overcome, and the resistance force is what the machine does to overcome that value. Skip this. Okay. When we look at machines, we've already been mentioning the work. So now let's talk about how they kind of interact with each other. So there are two kinds of work that we look at when we use machines, and that's work input and work output. So work in, and this is just an underlined in, I don't know why it's marked out, is the work done on the machine. So that's what we would do. And then work output, here. It's the product of the effort force and the resistance that force is exerted. So if it's, like a lever, how do we push that lever? The distance and the amount of force we put on the machine is the work input. And it's calculated this way with effort force times distance of the effort. And then we also have work output, which is what's done by the machine. So this is the machine's job. This is what it is doing. So how far does that lever lift something? So this is the product of the resistance force and the distance of that force. So it's Fr times dr, both resistance there. Remember, resistance force is the force the machine exerts on whatever object it's working on. And then the force of resistance is having to be overcome by that machine to move the object. So you can never make more work out of the machine than you put in. So your work output can never be higher than your work input, because some is always lost due to friction, things like that. And some energy will be changed to heat due to friction. So even in the most ideal situation, it's real life, we are going to have friction, and friction is going to change something's heat because we know that it's a sliding force or a rolling force, and it will cause heat to be lost from the system. Now, in a perfect world, we have what's called an ideal machine, and this is one where the work input equals the work output, and this is where no friction is involved. So we know that that's not really true, which is why it's called an ideal machine. We have some very close, but I don't think we have any that are perfectly ideal. So in an ideal machine, energy is conserved, and the machine cannot create energy. Remember, law of conservation of energy, it can neither be created nor destroyed, just moved from one thing to another. So now let's go over some simple machines you do need to know. You will need to be able to identify these and at least know some basic examples, which is what I'm going to show you here. So a pulley is a simple machine. You should know what that is. Think of like a flagpole, any type of rope on a pulley system. You've got a lever, which you can think of like a hammer. You can see here it's where you've put force on one side and the opposite side goes in the opposite direction. You've got a wheel and axle, so you can look at like a barbell here. For those of you that work out at the gym, you can think of like a car, wheel and axle. You've got a wedge, so how you can split wood when you put a wedge in it and you hammer that wedge in. You've got an inclined plane, so that's like a ramp, just a basic ramp. And then a screw, you've got screws that you've seen before, and that twisting motion that allows it to get on a helical axis. That's kind of what we're looking at there. So make sure you can identify these and know some basic, like real life examples of them.